Right. Okay, good morning. Today we will discuss the problems in Newton's forward interpolation formula. What I have done one or two problems in the last session. Okay, it is from module 5, 18MAT21 for second semester, module 5. So from the data, the problem is from the data given in the following table, find the number of students who obtained less than 45 marks and between 40 and 45 marks. Very simple statement. From the data given in the following table, find the number of students obtained less than 45 marks, and between 40 and 45 marks. So the table is given, the frequency table, that is marks 30 to 40, it is 31. Marks 40 to 50, it is 42. Marks 50 to 60. So you can see here 30 to 40. So here also 40 is there. So less than 40 will be here. 30 to less than 40 might be 39.5 like that. Here also 40 to 50 means it is only till 40 to 49.5. 50 is here like that. So 30 to 40 there are 31 students, the frequency. 40 to 50 there are 42 students. 50 to 60 there are 51 students, and 60 to 70 there are 35 students. 70 to 80 there are 31 students. Okay, let y is equal to f of x denote the number of students. So we have to make, we cannot calculate in Newton's forward interpolation formula when there is class intervals. Here there is class interval. So how to proceed? Let y is equal to f of x denote the number of students getting less than x marks. We take like this because here less than 45 marks, less than. So let y is equal to f of x denote the number of students getting less than x marks. Denote the number of students getting less than s marks. Y is equal to f of x denote the number of students getting less than x marks. Means y is equal to f of x denotes the number of students getting less than x marks. Y is equal to f of 45 means denotes the number of students getting less than 45 marks. Then y equals 31. See, y equals 31 for x equals 40. See, we take like this. Y equals 31 for x equals 40. Y equals 31 plus 42. 31 plus 42, that is 73 for x equals 50. We go on adding. That is just like cumulative. Y equals 73 plus 51, that is 124 for x equals 60. Y equals 124 plus 35, that is 159 for x equals 70. And y equals 159 plus 31 for x equals 80. So according to the given data, now the class interval table is rewritten. According to the given data, the class interval table is re-expressed as like this. See, when x is 40, y is 31. When x is 40, y is 31. Okay. When x is 50, y is 124. Sorry, when x is 50, y is 73. When x is 60, y is 124. When x is 70, y is 159. When x is 80, y is 190. I hope this is clear for you, how they have written it. Okay. Now, what is the step length here? See, first of all, you studied from the class interval how to convert it into single like this. How to convert it to a single. 40, 50, 60, 70, 80, y equals 31, 73, 124, 159, 159, 190, like that. That is the first step you have to understand here. Then it is simple, just like the previous problem. So step length here is 40 to 50, 50 to 60, 60 to 70, 70 to 80. Very clearly the step length h is 10. Step length h is 10, and the difference table we have to do now. So x value we write 40, 50, 60, 70, 80. 80. Y is 31, 73, 124, 159, 190. So when x is 40, y is 31. When x is 50, y is 73. When x is 60, y is 124. When x is 70, y is 159. When x is 80, y is 190. Now the first difference, second difference, third difference, fourth difference, if possible, fifth difference, if you get. Now here it ends in fourth difference, because in fourth difference, there is only one element. It ends in fourth difference because in the fourth difference there is only one element. Okay. Now first difference. How to find the first difference? See, 73 minus 31, what you get? 42. As before, you write this 42 in the middle of these two. 124 minus 73 is 51. You can use your calculator. 159 minus 124. 159 minus 124 is 35, right in the middle of these two numbers. 190 minus 159 is 31. So right in the middle like this. This is the first difference column. Okay, so forward difference, problems in forward difference. Then we go to second difference. So second difference means 51 minus 42, that is 9. 35 minus 51, so you get negative minus 16. Write it in the middle of these two. 31 minus 35 minus 4, right in the middle like this. And third difference. Minus 16 minus 9, that is minus 25. Minus 4 minus of minus, that is plus. Minus 4 plus 16, it will be 12. Minus 4, minus into minus will be plus. So minus 4 plus 16 will be 12. Then the fourth difference will be 12 plus 25. Minus of minus is plus. So 12 plus 25 is 37. Okay, I hope there is 2 marks for this, writing this table correctly. Now from the table it is very clear that x naught, the first value of x, from the table it is very clear that x naught is 40, y naught is 31, First difference, you are writing the first entries actually. Del y naught, that is 42, you can see here. Second difference, first entry, del squared y naught is 9. Third difference, del cubed y naught is minus 25. And the fourth difference, the last, del 4 y naught is 37. Now for x equals 45. Okay, for x equals 45, we find why x equals 45, because in the question they have given here, see, for less than 45 marks. So x is equal to 45 means f of x is less than 45 marks, because the function f of x is defined less than, see, let y is equal to f of x denotes the number of students getting less than x marks. Y is equal to f of x denotes the number of students getting less than x marks. Okay, now we find p. The formula for p is x minus x naught by h. The formula for p is x minus x naught by h. We have used it in the previous previous sessions also in the problems. So x is 45. What you have to find out? X naught is the first value you can see here. X naught is 40. Then h is the difference here, step length, that is 10. Okay, 45 minus 40, that is 5 by 10, that is 0.5. Now we write Newton's forward interpolation formula. Sometimes we can do the problem without writing formula also, but in the exam, always write the formula first. By Newton's forward difference formula, forward interpolation formula, by Newton's forward interpolation formula, see, f of x is 45, so written f of 45, f of x equals y naught plus p into delta y naught plus p into delta y naught plus p into p minus 1 by 2 factorial delta squared y naught. Now you can write the rest of the terms. It goes in some order. P into p minus 1 into p minus 2 divided by 3 factorial del cubed of y naught forward difference. Because del power 4 is there here, see, fourth difference is there, we have to go for the fourth also. P into p minus 1 into p minus 2 into p minus 3 divided by, this should have been 4 factorial, please correct it. This is not 3 factor, please correct it, it is 4 factorial. P into p minus 1 into p minus 2 into p minus 3 divided by 4 factorial. Please correct it, 4 factorial del 4 of y naught. Then we substitute all the values. Y naught is 31, p is 0.5. So 31 plus p is 0.5 into del y naught is 42 plus 0.5 into 0.5 minus 1 divided by 2 factorial is 2. Del squared y naught is 9. Written here. Next, 0.5 into 0.5 minus 1, 0.5 minus 2 divided by 3 factorial is 6. And del cube of y naught. Del cube of y naught is given to be, minus 25. So I written here, see. and 3 factorial is 6. P into P minus 1, this one, so P is 0.5 into 0.5 minus 1 into 0.5 minus 2 into 0.5 minus 3 divided by 4 factorial. 4 factorial is 24. 4 factorial is 24. Okay, 4 factorial is 24. So 4 factorial is 24. Then we have del 4 of y naught, and del 4 of y naught is 37. Now you know, now I need not tell you, you know how to do it, 37, and then use calculator. Use calculator. When you use the calculator, you will get 42.47. I might be wrong. Just check whether the answer is correct using the calculator. 47.8675. But this is the question is number of students. So number of students cannot be decimal. We cannot say 1.5 student. Always we have to approximate to the next whole number. So the number of students who obtained less than 45 marks is about 48. So the number of students who obtained less than 45 marks is about 48. Now we go to the next part. That is number of students who obtained less than 45 marks is 48. Next is between 40 and 45 marks. So between 40 and 45 marks, for that, since the number of students who got less than 40 marks is 31. See, number of students who got less than 40 marks is 31. Since the number of students who got less than 40 marks is 31, it follows that the number of students who obtained between 40 and 45, so less than 40 marks who got is 31. Therefore, it clearly follows that the number of students who obtained between 40 and 45 marks, it clearly follows that the number of students who obtained between 40 and 45 marks is till 45. Number of students less than 45 is 48. Number of students less than 40 is 31. So number of students who got in between 40 and 45 marks is 48 minus 31. 48 minus 31. So it is 17 approximately. This is the answer for the last problem in Newton's forward interpolation formula. Okay, Newton's forward interpolation formula. Now we go to Newton's backward interpolation formula. So many problems is enough in Newton's forward interpolation formula. Practice it. Try to solve the problem in the model question paper. It is the same type of problem. Only number is changing. Any doubt you can ask me, contact me. Now, Newton's backward interpolation formula. So, forward you have seen, backward it is just opposite. There is a change in the formula. There is change in the Newton's forward interpolation formula. We are taking the topmost values, first entries. In Newton's backward interpolation formula, we are taking the lowest values, like that. So the formula that determines an approximate value of y is equal to f of x near the ending values xn of x. So forward interpolation formula takes the values near the starting, that is near x naught. You have seen all the questions. If you see here they have asked what? In this question they have asked less than 45 marks. It is in the beginning, between 40 and 45, 40 and 45 marks in the beginning. But if they ask in the last stage in xn, then it comes under backward interpolation. That is explained here. That is the meaning of this sentence. The formula that determines an approximate value of y is equal to f of x near the ending value xn of x is given as follows. The formula that determines an approximate value of y is equal to f of x near the ending value, the last value, you will see in the problems, xn of x is given as follows. So the Newton's backward interpolation formula, you have to by heart it. Derivation is not there in your syllabus. So only your problems. So y is equal to yn plus q into, see the symbol of backward here. It is not triangle, it is reverse of that. So symbol of backward is reverse. Okay. So here yn plus q into del yn. This is the opposite triangle. If it's a triangle, it is forward. If it is reverse of the triangle, it is backward. So yn plus q into del yn. Then you can see a yn plus q into del yn. Then plus q in there, it was p into p minus 1 divided by 2 factor. Here it is q into q plus 1. Just remember the difference. Make out the difference. Plus q into q plus 1 by 2 factorial del squared yn. plus q into q plus 1 into q plus 2 by 3 factorial del cubed yn plus dot dot plus q into q plus 1 into q plus 2 goes on till q minus of n minus 1. That is q minus of q plus of n minus 1. That is q plus n minus 1. Why? Because here when there is the third term, when there is 3 here, it is q plus 2. So when there is n, it will be q plus 1 less n minus 1. Anyway, the last term will be q into q plus 1 into q plus 2 into q plus n minus 1 divided by n factorial. The last term is clear. Into del of the reverse of del, that is reverse of the triangle over n y, and this is the symbol of backward interpolation. Now what is q? The formula for q also changes. So it is q equals x minus xn by h. The value of q is x minus xn by h. The value of q is x minus xn by h. The value of p is here, what you have seen here already, x minus x naught by h. Here it is x minus xn by h. This is known as Newton's backward interpolation formula. So by heart this, write it in your notes. Okay. Now we will see some simple problems in this. It's just like a forward interpolation formula. A few changes in the formula and backward values are taken. So from the following table of values of y is equal to f of x. From the following table of values of y equals f of x, compute f of 0.53. Compute f of 0.53 using the backward interpolation formula. See the question. From the following table of values of y is equal to f of x, compute f of 0.53 using the backward interpolation formula. They are given here. Sometimes they will not give. But then if it is not given, how to judge? See, 0.53 value is the last stage. It is near to xn. So whenever they ask you to find f of x such that x is near to xn, then you have to use the backward interpolation formula. When the value of x is in the last stage, but in the forward interpolation formula they used to give in the beginning. You might see, note that. Here step length h equals 0.10, 0.30x, 0.40, 0.50. Difference is 0.10. So the step length h is 0.10. Difference table is like this. So now be careful. Same like forward, but little difference. The symbol is reverse. So first we write x value. We write x column 0.30, 0.40, 0.50, 0.60. Okay, 0.60. We wrote it. Then we write y equals f of x. That is when x equals 0.30, f of x value is 0.6179. When x equals 0.40, f of x value is 0.6554. When x value is 0.50, f of x value is 0.6915. When x value is 0.60, f of x value is 0.7257. So writing all these values. Okay. So you know how to write. Same like the forward. So much is same. That the first part is exactly the same. Then first difference. This is this minus this as before. 0.6554 minus 0.6179. So when we subtract, we get 0.0375. 0.0375. Here 0.6915 minus 0.6554. 0.6915 minus 0.6554. That is 0.0361. 0.7257 minus 0.0342. 0.7257 minus 0.6915. That is 0.0342. Second difference, method is same. So this minus this 0.0361 minus 0.0375. So this is bigger, minus 0.0014. 0.0342 minus 0.0361. It will be minus 0.0019. Again the next third difference, minus 0.0019 minus into minus plus 0.0014. That you get as minus 0.0005. Okay. Values just see whether I am correct. Use the calculator and just calculate it again. Solve the problem again. Don't simply assume. I might be wrong sometimes. So from the table, see now it is difference. From the table in the forward difference till now you took x naught, that is 0.30. Now we take the backward. So we take xn, 0.60. We take yn, there we took y naught, we took this y naught. Now we take here yn, 0.7257. We took 0.7257. Then we take this del yn, the reverse of forward difference, del first difference, it is 0.034, then del squared yn. Again we take, now we take the last values. In forward difference we took the leading values. Now we take the last values, minus 0.0019, and the last table is third difference. Del cubed of yn is minus 0.0005. Now to find the value of y for x equals 0.53, that is the question. To find f of 0.53 means to find the value of y for x equals 0.53. Okay, so q is equal to x minus xn divided by h. So 0.53, xn is 0.60 minus 0.60 by h, 0.1. So you'll get as negative minus 0.7. Now we use this in the backward interpolation formula. Backward interpolation formula, all of you know here. Q value, first difference in the last entry, like that, yn, etc. So what we get here? So yn, you return all the values, then using backward interpolation formula, f of x or y equals f of x equals f of 0.53. So first we write here yn value 0.7257 plus q into next this one del yn, first difference, so 0.0342 plus q into q plus 1, there it was p minus 1, here it is q into q plus 1 by 2 factorial, to the next difference, the del squared yn minus 0.019, then the third one, q into q plus 1 into q plus 2, that is q minus 0.7 minus 0.7 plus 1 into minus 0.7 plus 2 by 3 factorial, into the del cubed of yn, that is minus 0.0005. So calculation, I leave it to you. I have given the answer. See whether I am correct. Don't simply assume, don't by heart. 0.70198. F of 0.53 is 0.70198. Okay. We'll see another question now. I hope now by now you know what is the idea and what is the difference between forward and backward. Forward means the starting values near x naught. Backward means the near xn last. And when taking also, we take in backward the yn last values and the last entries of the columns. But in the forward difference, we take the first entries. The following table gives the values of y equals tan x for various values of x. The following table gives the value of y equals tan x for various values of x. So x equals 0.10, 0.15, 0.20, 0.25, 0.30. Y equals tan x is given 0.1003. It is given in the question. When x equals 0.15, 0.1511. When x equals 0.20, 0.2027. When x equals 0.25, y equals tan 0.25, 0.2553. When x equals 0.30, it is 0.3093. Find an approximate value of tan of 0.28. See, 0.28 is in the last stage. They have asked you to find an approximate value of tan of 0.28, and 0.28 is in the last stage. Okay. Now solution here, what is the step length? 0.10, 0.15, 0.20, 0.25. So the step length is h equals 0.05. Step length h equals 0.05. So the difference table, first we write the x values, then we write the y values. So x is 0.10, 0.15, 0.20, 0.25, 0.30. Y value, write all the y values. When x equals 0.10, this y values, you know how to write it, I need not say. First difference, 0.1511 minus 0.1003, that is 0.0508. Just verify. 0.2027 minus 0.1511, 0.0516. 0.2553 minus 0.2027, 0.0526, write it in the middle. 0.3093 minus 0.2553, 0.0540. Similarly, now going to second difference, 0.0516 minus 0.0508, that is 0.516. This is 508. So when you subtract 0.0008, write it in the middle. 0.0526 minus 0.0516, 0.0010, 0.0540 minus 0.0526, 0.0014. In third difference, 0.0010 minus 0.0008, 0.0002, 0.0014 minus 0.0010, 0.0004. Again, the fourth difference, because it goes, you can see one more. So 0.0004 minus 0.0002, that is 0.0002. Now from the table, xn is 30. Because it is backward difference, we take only the back values. So from the table it is 0.030 xn value. Then yn value is last value we take. For forward difference, we take the beginning values. Yn is 0.3093. Then del yn, last value first column, 0.0540, del squared yn 0.0014, del cube yn 0.0004, and del 4 yn, that is backward 0.0002. Now for y equals, to find y for x equals, it is given as 0.28. Okay, so q equals x minus xn by h. Okay, so x is 0.28 minus xn is 0.30 divided by h is subtract 0.15 minus 0.10, that is h is 0.05. Very clear. I've given in the beginning, step length h is 0.05. Now, when you substitute this, you get 0.28 minus 0.30 by 0.05. So you'll get the value as minus 0.4. This is very clear, minus 0.4. I hope it is clear till here, the backward difference. Now use the formula. Formula is first yn plus q into first del yn plus q into q plus 1 by 2 factorial del squared yn plus q into q plus 1 q plus 2 divided by 3 factorial del cubed yn plus q into q plus 1 into q plus 2 into q plus 3 by 4 factorial del power 4 yn, but it is the reverse of forward. Even symbol for forward it is triangle, for backward it is reverse of triangle. So substituting all the values, now yn, I have not written the formula. Exam better you write the formula first. 0.3093 yn plus q minus 0.4 into 0.0540, that is del yn, then plus q into q plus 1 by 2, that is minus 0.4 into minus 0.4 plus 1 by divided by 2 factor, that is 2 into del squared of yn, that is 0.0014. Then q into q plus 1 into q plus 2 minus 0.4 into minus 0.4 plus 1 into minus 0.4 plus 2 divided by 3 factorial into del cubed, that is 0.0004. Then the next is, because we have got fourth difference also, minus 0.4 plus 1 minus 0.4 plus 2 minus 0.4 plus 3 divided by 4 factorial, that is 24, into the fourth column, that is the fourth difference, last entry, 0.0002. Calculate this, you will get the answer as 0.2875. You will get the answer as 0.2875. Actually, tan of you will get 0.28 as 0.2875. Okay. Now, once again, you can see here. First of all, you should be able to, in this problem, they are not given use backward difference formula. See, like this in the exam, you should not get confused. In this problem, they are not given use backward difference formula. So how to make out that we have to use either forward difference formula or backward difference formula? You see this question, the following table gives the value of y equals tan x for various values of x. And they are given the values, and find an approximate value of tan. This you have to see. By this we can judge. Tan of 0.28. Find an approximate value of tan of 0.28. So 0.28 comes in the last near xn. Last value, 0.28 is here. So whenever they give the values of x in the last end, that is near xn, we have to use backward interpolation formula. Where you can see the problems in forward difference, they'll give the values near x naught. When they give in the beginning, then you have to use the forward interpolation formula. So I hope by now you know how to use this technique of backward interpolation formula and forward interpolation formula, when to use. So some more problems I will solve in the coming session. The next session I will solve some more problems in Newton's backward interpolation formula also. Okay, I have solved here two problems. More 3 or 4 I went solve. So my request to all the students is write the notes, solve the problems, don't simply read it, solve the problems and prepare from the model question paper, solve the model question paper problems, be easy. Use the concept I have explained. So now the time is up. So I like to summarize what we did today. So in today's session, we solved some problems in Newton's forward interpolation formula. Then I introduced Newton's backward interpolation formula and explained when to use Newton's backward interpolation formula and when to use Newton's forward interpolation formula. When the values, unknown values, find an approximate value that x, what they ask, is given near xn, near the end, then we have to use Newton's backward interpolation formula. When the values what they ask is given in the beginning near x0, you have to use forward interpolation formula. Then how to use the formula, also I told you. Difference table is same, method is same. How to use the formula I told you. So we will solve some more problems in the next session tomorrow at the same time. In the same time we'll solve next session tomorrow. So I wind up the session now. Thank you. All the best.